Welcome to Fantastic Vision. Please subscribe us before you watch today's video. In August 2023, Huawei launched the Mate 60 Pro mobile phone. This seemingly ordinary operation caused a shock in the entire technology circle. Unlike previous mobile phone releases, this mobile phone was sold before release and directly entered the market, and it shocked everyone's eyes. It is equipped with the Kirin 9000's chip, which was actually made by China itself without EUV, extreme ultraviolet lithography, support. In the current semiconductor industry, EUV lithography is almost synonymous with advanced chips. It is a must-have artifact for manufacturing 7 nanometers, 5 nanometers, and even more advanced process chips. And Chinese semiconductors can bypass this technology and make 7 nanometers chips by themselves. This breakthrough not only attracts attention from both inside and outside the industry, but also allows us to see a different image of Chinese core. How difficult is it to manufacture EUV lithography? In order to understand this breakthrough, let's first understand how awesome EUV lithography is. At present, the only company in the world that can manufacture EUV lithography machines is ASML in the Netherlands. This machine, which is worth up to $150 million, can be said to be one of the most complex and sophisticated machines in the world. Its working principle is like engraving a chip, but the knife for engraving must be thin and precise enough. ASML's EUV lithography machine uses a 20 kilowatt laser to bombard liquid tin droplets to generate plasma. The working environment of the entire machine is required to be cleaner than the surface of the moon. Not only that, there are more than 100,000 parts inside the EUV lithography machine. ASML can only provide 15% of the parts, and the remaining 85% depends on more than 5,000 suppliers around the world. This level of complexity is so complex that even the pursuers have no idea where to start. It can be said that making an EUV lithography machine is harder than climbing to the sky. So, when everyone was struggling with can China still make advanced chips without EUV lithography machines, Chinese engineers chose to take a different approach. They decided to bypass this dead end and find their own solutions. From another angle, play with multiple exposure. In the semiconductor manufacturing process, exposure is one of the most important steps, and EUV lithography relies on extreme ultraviolet light for extremely fine exposure. But since EUV is so difficult, why not try to use existing technology to break through? So, engineers in China introduced the multiple exposure solution. This concept is like the HDR mode we use when taking pictures. It uses DUV, deep ultraviolet lithography technology, to improve resolution and accuracy through multiple exposures. Simply put, it is to repeat multiple shots and then synthesize them in the later stage to achieve higher accuracy. In 2020, Liang Mingseng's team at SMIC used DUV lithography for the first time to realize the N+1 process and made a chip equivalent to 7 nanometers. Although the cost is 30% higher than EUV and the yield is also worse, at the time, this breakthrough was simply a heaven-defying operation. By 2023, SMIC's N+2 process has further improved the density of transistors, which is equivalent to using equipment from the 1990s to make aerospace-grade chips. In addition to multiple exposure, another secret weapon of China's semiconductor industry is the advanced packaging technology. The representative of this technology is Changjian technology. The XDFOI technology they developed can package chips of different processes together like building blocks, and finally combine them into an overall system with performance no less than a single 7 nanometers chip. Imagine if you used Lego blocks to build a transformer. Although the fineness of each part is not enough, the overall function is still powerful. This is exactly the building block splicing strategy of Changjian technology. In 2023, Huawei announced a patent for chip double stacking. After packaging two 14nm chips, the performance was improved by 80% and the power consumption was reduced by 30%. This idea completely subverts the traditional process competition logic. In the past, everyone was competing to make whose chips smaller and more precise, but now the practice is, since it is impossible to make smaller transistors, the existing chips can work together through intelligent packaging to improve the overall performance. In addition to manufacturing processes and packaging technology, material innovation is also one of the important paths for China's core breakthrough. In 2022, a team from Tsinghua University published an exciting study in the journal Nature. They successfully used the two-dimensional semiconductor material, molybdenum disulfide, to replace traditional silicon materials. The transistor thickness of molybdenum disulfide is only 0.7 nanometers, which is much thinner than the material of the current 3 nanometers chip. Although this material is still some distance away from commercialization, its appearance means that we can explore new overtaking paths, and even make the limits of chip manufacturing more blurred. What's more powerful is the graphene chip displayed by Beijing Yuanshan Carbon-Based Integrated Circuit Research Institute. This material can theoretically increase the speed of the chip by 10 times. Although it is still in the experimental stage, the potential of this technology has shocked the entire semiconductor industry. In the face of the barriers of EUV technology, China's breakthrough is not only based on homemade methods, but also involves the counterattack of domestic lithography machines. Shanghai Microelectronics' 28 nanometers DUV lithography machine was originally scheduled to be delivered at the end of 2023. Although it is 10 years behind ASML's EUV lithography machine, it has been able to achieve the production of 14 nanometers chips with the multiple exposure technology. What is even more surprising is that the SSMB EUV solution proposed by the Tsinghua University team, a technical concept of using particle accelerators to generate extreme ultraviolet light, if successfully implemented, will greatly reduce the size of future lithography machines, and even be as big as a container. These seemingly crazy ideas are the embodiment of the innovative spirit of China's semiconductor industry. To realize these ideas, a lot of money and resources are invested behind them. In 2022, China's semiconductor equipment procurement has reached $28.3 billion, of which domestic equipment accounts for 35%. SMIC has not only built multiple new factories in Beijing, Shanghai, Shenzhen and other places, but also specially reserved DUV production lines, showing their determination in mature processes. At the same time, Huawei's R&D investment in the first half of 2023 was as high as 82.6 billion yuan. This investment even reminds people of China's determination and strength in developing atomic bombs. Of course, any technological breakthrough is not without cost. The cost of using DUV lithography machines to make 7 nanometers chips is 50% higher than EUV, and the electricity bill has also increased by 30%. In addition, although the packaging technology is ingenious, it also requires the redesign of the system architecture, and the software ecosystem must also be changed accordingly. More importantly, the upper limit of these wild ways is also very clear. The limit of multiple exposure is around 5 nanometers, and advanced packaging cannot solve the problem of excessive chip size. However, this strategy has allowed the Chinese semiconductor industry to find its own place in the global competition. Even if it cannot catch up with the most advanced EUV technology immediately, Chinese companies have already expanded against the trend in the market above 28 nanometers, and leading technologies and products have emerged in an endless stream. Global game, the contest of technology and politics. The game behind all this is both a technical contest and a political contest. China's chip breakthrough has brought new challenges to the sanctions policies of the United States and other countries. ASML has just obtained permission to export 2,000 EUV lithography machines to China, and this move is obviously a compromise forced by China's breakthrough in the process of independent research and development. Just like the photovoltaic and high-speed rail fields, China's semiconductor industry is also gradually breaking the international blockade through independent innovation and opening its own road to counterattack. In the next 10 years, the exciting part of this global semiconductor competition has just begun. In 2025, the global semiconductor game will enter a new stage. EUV lithography will not be the only secret to pass the level. Just as no one thought that electric vehicles could make a comeback in the era of fuel vehicles, the future semiconductor competition will be a melee with multiple technical routes coexisting. From China's extreme operation, we can see that innovation is not only a technological breakthrough, but also a strategic vision.